is entirely Canadian, starting with ourselves, York Universe. On to Quirks and Quarks, Science for the People, and Western Worlds. New episodes for Quirks and Quarks and Science for the People. The York Universe broadcasts every Monday night, 9 p.m. local Toronto time, or that's Tuesday morning, 2 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team. Hi there, guys. It runs, not surprisingly, between the hours of 9 and 10 p.m. local Toronto time. By all means, point to your favorite web browser to observatory.info.yorku.ca and follow the links to OPV, online public viewing, and join the chat and have a look at the live imagery. Yes, it is clear here in Toronto. That's what happens when you get minus 12, minus 13 degrees Celsius. It's nice and clear. So live imagery from the 1 meter telescope. By all means, join us, please. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you might have about past shows or suggestions for future topics, by all means, send us an email, observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory. And on Facebook, Allan say that slowly, Paul. Allan Carswell Obs. That's all running together. All of our programs are free, but if you would like to make a donation, by all means, please visit our website, observatory.info.yorku.ca, and look for that big friendly donate button. We are, of course, monitoring the chat room for questions, and we'll post content there. The current weather, as I indicated, is nice and clear. So by all means, check out those wonderful 1 meter telescope images. Satish, I think you said you saw the moon last night.
Actually, it was like last night and day before the last, and then probably the day before the last as well.
In other words, it's been very clear on the West Coast.
Yes, and that's a luxury, trust me. Like,
absolutely.
We don't have clear skies today.
Yeah. No, it tends to be cloudy from July 1st to June 30th. But anyway, I'm glad you managed to see the moon. And, of course, you're outside observing it, and you didn't have to wear 13 layers and a coat on top. So we're very envious here in the East.
Yeah, I can't help it. Sorry.
Voyager, have you taken any images of the night sky recently?
Not recently. I haven't had the chance to really go out, and it's really, really cold. But I'm planning on hopefully doing some live imaging online through iTelescope or through like our telescope as well. That's still open.
It certainly is.
Okay, yeah, I'm going to take some time off and of like doing work and like studying to take some images in the next few weeks.
Sounds like a good plan. Take the opportunity while you have a little bit of free time, because it becomes precious and few before too long.
Oh, yeah.
And both of you should mark your calendars now, because in May we have a nice total lunar eclipse on or about May 16th, if memory serves. So if either of you are interested in a little bit of lunar photography, plan now, because this is going to be a good one. It's available relatively early in the evening and visible from all across Canada all night.
I'm looking forward to it, definitely.
That's your early heads up. Okay, we've got lots of good stuff to cover, so let me lead us in here, folks. Let's wander on back to, February 12th, 1947, and I'm going to be really specific, 10:30 in the morning, local time. Where, of course, is the local time? Well, we're talking about southeastern Russia. That, for those who haven't dug out a map recently, that's basically straight north of Japan, just on the coast there. Okay, why am I directing you to this very unusual location at this very specific time? Because if you were there at that moment in time, you would have been witness to one of the largest meteorite falls in history. This was the famous Sikhote-Alin meteorite fall, and a fall, of course, is just the general term for when meteorites rain from the sky. Most of the time, of course, they land in the ocean or in very isolated areas, and you don't get to see them. But on this occasion, there were lots of witnesses and nearly 23 tons of meteoritic material came to ground. I'll say that again. 23 tons of material. That's 23,000 kilograms of meteorites coming to ground. So this was a very sensational fall, and it missed everybody, which is even better. It was an iron meteorite. The Cicodeline was an iron meteorite, which basically means that the material on the ground was 93% iron and 7% everything else, of which most of that was also other metals, but 93% iron. As I said, it is the largest recorded observed meteoritic fall on record. The meteorite is estimated to have entered the Earth's atmosphere. This is based upon the reports and the correlations and then the modeling, about 14 kilometers a second. So it was moving along. And of course, when these sorts of objects hit the upper atmosphere and the density of the air begins to increase, not surprisingly, meteorites basically explode and you have airburst explosions. And of course, given the size of this meteorite, given the amount of speed that it was shedding as it came through the atmosphere, it would have been quite the airburst explosion. Heard hundreds of kilometers away, so the reports go. Initial mass entering the atmosphere, we're guessing at about 100 tons. So it lost about 75% of its mass during atmospheric entry, as of course it heats up, ablates, and sheds a lot of that kinetic energy. The origin for the meteorite was, in all likelihood, the asteroid belt. We can get a bit of a handle on the orbital trajectory of meteorites if we've got enough eyewitness reports. And of course, in this day and age, that generally equates to CCD images and dash cams and so on. So the determination of the orbital trajectory is much more accurate today. But the Cicodeline fall was so well observed during the day, so incredibly bright, that the Russian Academy of Science believes that they had enough information to trace the trajectory back and are quite confident that it emanated from the main asteroid belt between Mars and Jupiter. The impact area for the Cicodeline, for the 23 tons of material that landed, was about half a square kilometer, and the biggest piece that hit generated a small little crater about 26 meters in diameter. This was an impressive fall by any measurement you care to consider. The amount of material, of course, has generated literally hundreds and hundreds of meteorites in public circulation. The biggest pieces are at the Academy of Science in Russia, in Moscow, but thousands, probably not hundreds, thousands of smaller pieces have ended up in public circulation. And I'm just going to throw this out to Satish and Palvisha. Do you remember handling the meteorite that we have at York in the department?
Oh, I do.
Okay. Well, you are handling a piece of the Cicodeline. So this is the history, this is the backstory for that piece of meteorite that we picked up in, from public, well, not public. It was in the public domain at a private dealer. We picked it up about 10 years or so ago. So that piece of meteorite that you held came from the asteroid belt, landed on Earth in 1947, February 12th, 1947. So you have a piece of history, not just a piece of the universe when you're handling that meteorite. Anyway, that was the big fall, 1947, February 12th, 10:30 in the morning in southeastern Russia. Cicodeline meteorite.
I've been looking at the images, Google Maps and all. And it's a pretty secluded place, of course, and beautiful. So should we be happy that it actually did go there and not anywhere else, where people were actually living?
Well, you're absolutely right. I mean, if that had come down, a few hundred kilometers further south, it would have ended up in Japan. And the population density there is significantly higher than southeastern Russia. So in a way, it was fortunate that it came down. But there were enough people to observe it and to give eyewitness reports and so on. So it struck a really good balance. It didn't hurt anybody. It didn't kill anybody. But there were enough people to see this very, very impressive sight. I mean, having 23 tons of material rain down from a clear blue sky would A, be scary, but B, very, very impressive.
And
That's
still
actually
after.
very, very scary, I would still say. That's a lot.
And that's still after like 75% of it was lost.
Yeah, fortunately, that's exactly right. I mean, this is standard operating procedure for a meteorite. Of course, it hits the atmosphere. It's actually a meteor at that point. But this was sufficiently large, although I've not actually seen an estimate of the diameter, but it would have been, I would suspect, tens of meters in diameter, perhaps as much as 60, 70 meters in diameter. It would have been a good sized piece of rock at any rate. And landing on the surface turns it from a meteor into a meteorite. Being an iron meteorite, it's actually able to survive atmospheric entry better than, say, for example, the silicate meteorites, the stones. They tend to disintegrate more easily because, of course, their melting points are much lower than iron and other metals. Impressive meteorite fall is the bottom line to it. Palvisha, I think you want to take us off planet.
Right. So for the next space history item, Voyager 1 captured the first image of our solar system today, February 14th, 1990. So Voyager 1 is a NASA spacecraft that was intended for a flyby mission, and that mission was launched on September 5th, 1977. Voyager 1 also had a 2. Voyager 2 was launched first, and Voyager 1 followed shortly after. Both of them were designed to fly by the planets of our solar system, and they were launched in that specific year. They were intended to fly by the planets in that year because of a special alignment of our planets that happens once in 176 years, where along their trajectory, they would be able to pass by all of the other planets. And so both of them were sent off for that mission, along with a bit of a time capsule on both of them, which is the golden record that contains the sounds and images of Earth, along with the location of where Earth is. So both of them were launched, and on February 14th, 1990, several decades after its launch, Voyager imaged our solar system. It took a series of around 60 images, where one of those images was the famous pale blue dot, which was taken at a distance of about 6 billion kilometers from the sun. In addition to Earth, Venus, Uranus, Jupiter, and Saturn were also imaged. Because, again, Voyager's trajectory was along the path to all of the planets, it also explored the Jovian moons, and it also basically continued on its path out of our solar system and remains only as one of only 3 spacecraft that were able to escape our solar system. So a very successful mission, of course.
Happy Valentine's Day to everybody on Earth, courtesy of Voyager 1. Yeah, they chose the date very deliberately, shall we say. Yeah, the Grand Tour was quite the undertaking. The expectation in the 70s was that this would be one of the missions to end all missions, so to speak. And it was. I mean, you only get to fly by planets for the first time once. And the Voyager probes managed to do Jupiter, Saturn, Uranus, and Neptune, in spectacular fashion. Voyager 2 managed to pass by all 4 of them. Voyager 1 managed only Jupiter and Saturn. But when you think back to their exploits, the technology that was available to NASA in the 1970s, as you said, Palvisha, a spectacularly successful mission for both Voyager 1 and Voyager 2.
And I think as late as last year, it's working, of course. And it detected something of a hum in interstellar space.
You're right. Voyagers 1 and 2 continue to explore beyond the heliopause. So they're out beyond that particular line that marks the difference between where the sun controls this, the environment and where interstellar space actually starts. Both of those spacecraft have now moved beyond that line. Is that the hum? So yeah, they continue to operate. Their instrumentation, of course, is not as operational as it once was. For example, the cameras have all been turned off and the power redirected because there's nothing to image out there. So there's only a few of the instruments that are still active, but they are transmitting data, I believe, either once a week or once a month, basically outlining the environment through which those two spacecraft are flying. So yeah, here we are, 1976, I think you said, Palvisha. So that's, getting on to what, 45, 46 years now. Not bad.
Not bad for a spacecraft.
Yeah.
I'm surprised it's still capable of sending signals from that far away.
And we're able to hear them. I mean, it's a treat in many ways, and a real toast to the actual engineers who built the spacecraft, as I said, all the way back in the early 70s. I mean, the onboard computing technology, your phone would run rings around them. I mean, it's quite amazing when you think about it. Anyway, good stuff, Voyager, and happy Valentine's to the entire solar system. Few birthday shout-outs, I think, Satish.
Yes, sir. I'm not sure how many we can probably fit in, but I'll try and look for. Start with Galileo Galilei, February 15th, and he was born in 1564, which is not too long ago. So not that he requires any introduction, but he was an Italian astronomer, physicist, and engineer. I don't know how he was an engineer, but a physicist is enough. He is known for his pioneering work in observational astronomy, modern physics and science, and somehow even the scientific method. I'm just kidding. He did work on all basics of speed and velocity, gravity and free fall, relativity, inertia, projectiles, pendulums, and hydrostatics. He even invented the first version of a thermometer and I guess the military compass. He gave us most of the first year physics lab experiments, is how I kind of can sum up whatever is listed in his works, the basic works, of course. And obviously he put the telescope to proper good use for the first time, even if he didn't invent it, which he did not, of course. And, he looked up and down the sky, studied the phases of Venus, 4 of Jupiter's moons he discovered, and Saturn's rings, lunar craters, and sunspots. And most effectively, he put the Copernican view of the solar system in good perspective for the rest of the world, for good, because the world really didn't actually roll back to any other version after that. And then, of course, there are stories about him and the church, which are as intriguing as they're sad, though. But definitely a huge, birthday shout out to Galileo Galilei. And
why don't you go on and do Spyro Harriet as well?
Absolutely. So this is 1851, a couple of centuries, actually 3 centuries after Galileo. Spyro Harriet was a Romanian astronomer, and he was even a politician. His name calls for an honorable mention for his fundamental contributions to solving the n-body problem in celestial mechanics, essentially by employing third-degree approximation to establish an instability of the major axes in orbit, a general rule, so to say. And hence he introduced the idea of secular perturbations in this, which probably was his political motivation as well. Again, a joke, but happy birthday, both of them.
Certainly of the two, Galileo is, shall we say, far more prominent. But, when you think about trying to solve the n-body problem without a computer, not for the faint of heart. So tip of the hat to Harriet for going down that pathway. That's non-trivial. It really isn't. Yeah, Galileo, though, when you think about his achievements, it really is quite amazing. Yeah, we won't go into the dispute that he had with the church because that could take up the entire show. But
Yes.
Galileo in the early part of the 17th century was certainly instrumental in cementing the worldview held by Copernicus and others, that is to say the heliocentric view. And as far as being an engineer is concerned, Satish, of course, he built his own telescope. So, I mean, that's not for the faint of heart either. So there's your engineering prowess.
I was just kidding. So I was just like saying those people at that time didn't really need or don't really need tags of what branch of physics did they actually belong to. Or I'm just like laying my own thing here.
They were jacks of all trades. Jacks of all trades.
Yes. In fact, sometimes I wonder if there was ever a term which could be, or if one could ever call them masters of all trades. Maybe it was these people. It was Newton, of course, and then there were quite a few during those centuries.
Well, that's true. Back in the 17th century, you could really be shall I say, a multifaceted academic. But as the centuries roll by, as each discipline became far more intense, shall we say, it became harder and harder to be so broadly educated. You had to begin to specialize, as we do today.
Yes, sir. That's my bad luck. Thank you for pointing out.
You're living 300 years too late. Is that what you're saying?
I guess so. Yeah, that's my excuse for, not being the master.
Palvisha, did you ever look through my Galileo telescope?
I believe I haven't. I don't actually remember.
I was going to ask you what was your recollection, but I won't ask you that.
Yeah, I don't think I have. But it makes me wonder how school must have been for them, or how university must have been for them back then.
There was no school. I don't know.
Oh, I mean,
just kidding.
Yeah, that's true.
It would have been every bit as tough, rest assured. Don't think that they had it any easier just because they didn't necessarily specialize in one topic or another. It would have been, I'm sure, every bit as challenging for them. And we are able to do what we do today as a result of their accomplishments. They laid all sorts of foundations, as did others. I mean, not just, Galileo and company. All of the scientists from around the world, from all of the cultures, have contributed a significant base of knowledge upon which we work today. So, again, a tip of the hat to our forebears in this regard from all around the planet. Okie dokie. All right, let me drag us out into the solar system yet again. This time a little more recently, February 17th, 1996. All right, and before I go any further, here we go, just to test my co-hosts' general knowledge. Name for me the various asteroids that have been visited by spacecraft. Give me anyone. Give me anyone, Satish.
I'm not even raising my hand because I just had some name at the tip of my tongue and I forgot. There was one Japanese mission to some asteroid.
Okay.
I'm forgetting the name.
There was the New Horizons mission.
You're giving me the names of spacecraft that did the work. Neither of you are giving me the names of any of the asteroids yet.
I'm Googling them. So.
Oh, you're Googling them. Oh, stop that. That is cheating. And I can hear Palvisha quietly working too in that regard. Okay, all right. No, Google's is not counting. Okay, so of late, because of the Japanese space agency, JAXA, wandering off to the asteroid Ryugu, or the earlier one, Itokawa. But there is also, of course, the OSIRIS-REx mission, which is on its way back from Bennu. You could be forgiven for thinking that, gosh, we've only gotten around to doing asteroid engagements with spacecraft in the recent decade or so. If you were thinking along those lines, then I would find my biggest buzzer and go, and say, nope, nope, nope. Let's go all the way back to 1996 and the Near-Schumacher mission, NEAR. That mission was launched February 17th, 1996, the Near-Earth Asteroid Rendezvous mission. And this spacecraft was bound for an asteroid by the name of 433 Eros. It was planned to go into orbit around that asteroid. Now, 433 Eros is an Apollo asteroid. That means it is an Earth orbit crossing asteroid. Therefore, one of those that potentially could be hazardous to one's health, aka the planet's health. And this is a big asteroid. We're talking about 13 by 13 by 33 kilometers. This is a big asteroid. You do not want to argue with this asteroid, okay? The Earth does not want to argue with this asteroid. But because of its orbit, it was in a really good position for us to rendezvous with. And that's what NEAR was planned to do. It was the first of NASA's Discovery missions. Okay, so we've been flying Discovery class missions. These are sort of faster, cheaper, better that have been flying since 1996. The total cost of this mission was less than $200 million. And anyway, we fly off with Near-Schumacher, Schumacher after Eugene Schumacher, who was the person who did all sorts of wonderful things, recognizing crater activity here on Earth, including the Arizona Barringer Meteor Crater. So Near flies off in February of 1996. The plan was to engage Eros 433. Just for grins and giggles, it flew past Matilda 253 on June 27th, 1997. The big effort was set for December of 1998. In other words, NEAR was supposed to go into orbit around Eros in late 98, early 99. And of course, the most critical moment for any of these types of maneuvers is when you fire the engines to ease into orbit around said object, in this case, Eros. The burn had just started on December 20th. I'm building the excitement here. 2 minutes into the burn, and it shut off, and the spacecraft went into safe mode. Safe mode, you might recall, is when the spacecraft says, there is something wrong, and I don't know what to do. Tell me what to do. At that point in time, it also began to tumble, which meant that, of course, mission control that is going, hello, talk to me, can't talk to the spacecraft. For nearly 24 hours, NEAR is in this roll situation. The solar panels are no longer facing the sun, therefore the onboard battery power is dropping. The thrusters are going off, so we're expending propellant. Nearly 29 kilograms of propellant were used while the spacecraft tumbled. Needless to say, it was a harrowing 24 hours. NASA did manage to regain control of NEAR, but the opportunity to fly into orbit around Eros had been lost. So they got the spacecraft under control. There was still enough attitude control gas as well as onboard propellant for the main engine, but Eros was now in the rearview mirror. So they went round the sun one more time together, and they tried again the following year, and this time it was successful. So we had successful orbital insertion February 14th, 2000. Only a year late. What the heck? It stayed in orbit, a 200-kilometer circular orbit for a while. It then snuck on down to 35 kilometers circular orbit, did lots of wonderful science, all sorts of instrumentation on board, gamma ray, X-ray spectrometers, near-infrared imaging, CCDs, whole battery of filters. You name it, they had it, magnetometers. It was a fabulously successful mission. They were able to examine this object in great detail, got a really good handle on the morphology. It was in orbit for over a year. And then the piece de resistance. They decided they wanted to land NEAR onto Eros. That was never in the mission plan, but they decided, hey, what the hell? We're going to try and put it down. They put it down so softly onto the asteroid that it didn't stop transmitting. And everybody at Mission Control looked at each other and sort of said, hey, the spacecraft is still working. And so they extended the mission for another 2 weeks. The landing took place on February 12th, 2001. And as I said, the spacecraft was still working. So they extended the mission for 2 weeks more because, of course, they wanted up close and personal imaging as well as doing gamma ray spectroscopy of the surface. And so anyway, it was a fabulously successful mission. After that period of time, by the way, the solar panels that were no longer pointing optimally at the sun, they were probably lying on them. They sort of had to shut it down. So the era of asteroid rendezvous started back in the late 1990s, early 2000s, folks. It was it heralded greater things to come from both JAXA as well as NASA. And let's not forget Rosetta and its orbit of the comet Churyumov-Gerasimenko. So this all started with Near Schumacher in the late 1990s.
Shouldn't they just call it like the Valentine asteroid?
It sounds like February was a nice month for this mission.
Well, it certainly was. All of those February important dates and so on. February 14th certainly played a role in some of the mission objectives. But it had a phenomenally successful run, given the fact that they almost lost it before it even got to the asteroid. So there you go. Add that to your list of asteroids that you couldn't remember, people. Bennu, Itokawa, Raguyu, and Eros 433.
Happy birthday.
Yeah. Okay, Pioneer 10 to the other end of the solar system, Voyager 1, and now Pioneer 10, Palvisha.
Right. So February 15th, 1973, Pioneer 10 made history by becoming the first spacecraft to cross the asteroid belt. So Pioneer 10 was the first of NASA's missions to the outer planets, and it was also, like Voyager 1, intended as a flyby mission with a duration of about 21 months, but ended up lasting for more than 30 years. As the first craft to be set for the outer solar system, Pioneer 10 completed many firsts, and this includes becoming the first spacecraft placed on a trajectory to escape the solar system into interstellar space, becoming the first spacecraft to fly beyond Mars, the first spacecraft to fly through the main asteroid belt, the first spacecraft to fly past Jupiter. It also became the first human-made object to go beyond Neptune, and was the first spacecraft to use all nuclear electric power. So in terms of its journey, Pioneer 10 was launched on March 2nd, 1972. And then on February 15th, 1973, it became the first spacecraft to cross the asteroid belt. On February, I'm not sure what the date was for that, but in February of 1976, Pioneer 10 crossed Saturn's orbit. Then it crossed Neptune's orbit on June 13th, 1983. But after that, in 1997, routine contact with the spacecraft was terminated, and we eventually received its very last signal on January 23rd, 2003. During its trajectory, or during its journey through the asteroid belt, it was hit by asteroids, but did manage to make it through. And while on its journey, it was able to take details or record details of one of the most violent solar storms in recent history, measured the zodiacal light, and you would definitely say that it was a very successful mission, because it was intended for just almost less than 2 years and lasted for 3 decades.
And again, they don't make them like that anymore. I mean, it really was a phenomenal effort, and it was, one of the real highlights, shall we say. We had just finished all of our lunar activity, going to the moon, last man on the moon, December of 72, and here we are setting sail, if you will, across the solar system in March of 72. So, we were just finishing up the moon landings, and already NASA is engaged in this type of activity. Not as grand a tour, shall we say, as the Voyager missions were expecting to have, but still to be able to head out into the outer solar system for Pioneer 10, and then its sister spacecraft Pioneer 11. Really, really exciting stuff there from the early 70s.
Yeah, I think that was one of the best times for space exploration and space travel.
Well, as I say, you only get to go by these places first once. And I actually misspoke earlier. The Voyager spacecraft weren't the first to get to Jupiter and Saturn. That was Pioneers 10 and 11. Voyager did get on to Uranus and Neptune for the first time, but it was actually the Pioneer spacecraft, Pioneer 10, getting to Jupiter first. Pioneer 11 got to Saturn first, and then the Voyager spacecraft followed thereafter. So, I remember these missions so very well because everybody was still quite excited about space exploration. As I said, we just finished going to the moon. The Skylab missions were forthcoming in 1973. They were talking about the space shuttle and the possibility of flying space shuttles into orbit every week. So, it seemed that NASA could do no wrong in this regard. And the Pioneer and the Voyager spacecraft were sort of testimony to that. And I won't even stop to talk about Viking in 1976 and the surface of Mars. But, Pioneer 10, real trooper of a spacecraft. Satish, finish us off, please.
Okay, so sure. So this is, I've kept it small because I really can't talk enough about this. February 19th and the 20th, sometime there, whichever time zone, the first space station for the human race, Mir, was launched in 1986. And Mir means peace. I'm not sure how much it actually meant. It was launched with the core module from Russia and one part from the Kennedy Space Center. It was later assembled in low Earth orbit and used to maintain a rate of 15.7 orbits per day, pretty specific number. It was the heaviest spacecraft to be ever launched until that time and stayed in orbit for the next 15 years. The first launch was aboard the Proton K rocket for people who are interested in rockets. And it was joined by another 6 modules assembled over a period of 10 years in space. It basically took 10 years to just assemble it. And I think it was decommissioned in 2001. So 5 years of complete service. It was perhaps the first sustenance of microgravitational environment in space for long periods. And it remained the hub of the longest sustainable human presence until the International Space Station broke that record in 2010. And like I said, in 2001, it did return to Earth in pieces all over the South Pacific in March of 2001. So happy birthday, Mir, generally.
Quite the forerunner to the ISS. In many ways, the ISS owes its existence to the experience of the Russian orbiting space stations. Salyut first, but Mir was by far the most successful. Did very well, compared to the ISS. Yeah, it looks a little rudimentary. If you look at imagery from inside, it was definitely a little more cramped, but it paved the way for an understanding of how space stations can operate. And as you indicated, it was, many, many years of operation. What was it, 86 through to 2010? No,
yes.
Was it 2010 it came down? 2001.
86 to 96 is the 2001 it came down. 86 to 96 is what it says it took to assemble that in the 10 years.
Right.
And of course, I misspoke. Salyut 1 was way before this. I just didn't realize. Sorry about
it. That's okay. But 15 years. So Mir was operational for 15 years is what it amounts to. It was decommissioned once ISS became operational, and ISS became operational in November of 2000. So yeah, Mir did a great job, and we brought it down in a very safe, controlled fashion. I mean, it dumped itself into the graveyard of the South Pacific, which is par for the course. So yeah, Mir really was a workhorse. I'm quite impressed with that technology from the 80s.
I wonder what they'll put up next to replace the ISS, because I believe, I think in 2031, if I'm not mistaken, or 2030, I believe the ISS is supposed to be decommissioned as well.
It is. That is the current game plan from NASA. But I said this a couple of weeks ago, and I'll say it again. It would not surprise me if the ISS gets signed over to private enterprise, to commercial interests. And so instead of bringing it down, it transitions from the current international collaboration to a different collaboration, and they keep it operational in orbit. I would not be at all surprised if that happens if the ISS is still operating well. Of course, that's a big if. It's 10 years further down the line. But if it's still operational in a satisfactory and safe fashion, it would not surprise me if NASA, the Russian Space Federation, and the other colleagues decide to keep it going. But we'll see. We'll see. By the end of this decade, I expect we'll find other space stations in orbit with commercial enterprises. So exciting times ahead.
I think I read something about that they're trying to put up an inflatable space station.
The Bigelow inflatable has been docked with the International Space Station now for about 4 years, showing that technology is viable. And then other groups are thinking of doing that. Axiom Space is looking to the future. So too is Blue Origin. Stay tuned. It's an exciting time. Palvisha, you might be able to, pick an anniversary or a birthday present to yourself 10, 15 years from now. Quick trip into Earth orbit.
That would be really cool.
You might have to win the lottery, but
I'll
folks,
check it out.
right. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory here at York University in Toronto, Ontario, Canada. You're listening to Satish, Palvisha, myself, Paul, keeping you company with This Week in Space and Astronomy History. By all means, join the Observatory team over at observatory.info.yorku.ca. Live imagery from the 1 meter telescope. It's a spectacular evening, so pop over there, follow the links to OPV, online public viewing, for those wonderful images. Speaking of the Observatory team, this Wednesday evening is Teletube. This is the weekly broadcast of the Observatory team on YouTube from 7:30 to 8:30. This week, we're actually co-hosting or broadcasting on the shoulders of the Royal Astronomical Society of Toronto, the Royal Astronomical Society of Canada, Toronto Centre. It is their speakers night, and Vivian Tan from York University is presenting this week, a history of galaxy quenching over cosmic time. So that's basically over the last 14 billion years. She's going to cover all that in about 45 minutes. By all means, tune us in, as I said, on YouTube, Allan I. Carswell Observatory, and that'll be 7:30 Eastern Time this Wednesday. Right, we've got a couple of news items to share with you folks. The big news out of the black hole arena is being brought to you by Satish.
Okay, I'll be happy to cut it short and talk
No, just meander along. Go for it.
All right. Okay, so my headline, just in case someone's interested, is Astrometric Microlensing reveals an invisible black hole, and that's a first. So these astronomers, whoever they are, of course, doesn't matter, they used the Hubble Space Telescope over 8 epochs spread across 6 years, carrying out precise astrometry and a high magnification microlensing event in the direction of the galactic bulge, that is our own galaxy's bulge. And then the object thus detected is a stellar mass black hole of the invisible variety. And also, it's a first instance of the mass measurement of such an invisible black hole. So two types of gravitational lensing approaches were sort of deployed or employed actually, to arrive at this unique finding. They first noticed a magnification of distant stars, of a particular star's light, for a very short duration, and then it returned to normal. So this was an anomaly. This prompted them to realize that the absence of any foreground object, which means nothing that we could really see directly, that might explain such a magnification via lensing, and it suggested it could be a loner black hole. And then it led to the 6-year-long research to confirm this was indeed a black hole, not just another faint star. And they did this by working on how far the star appeared to move when the light was altered, so to say, employing the theory of the parallax. And then the black hole is supposed to be about 7 times the mass of our sun, and it sits perhaps not more than 5,000 light years away from us, which is pretty close astronomically. And if it was a star for us, we could have noticed this. So hence, it's, again, very close. And the black hole, which cannot be seen, has been confirmed. More details can be read on the archive.org in the paper titled An Isolated Stellar Mass Black Hole Detected Through Astrometric Lensing. It's pretty fresh, hasn't even been peer-reviewed yet.
Pretty impressive. I mean, black holes by definition are black, so very, very hard to see by themselves. Mostly we find them, of course, in binary or binary associations or trinary associations, because they tend to engage with the other stars of that multiple stellar system, and accretion disks, X-rays, and so on and so forth. Relatively easy to find a black hole that way, but to be able to find it out in the field, as has apparently been done here, very neat observations, and really handy to be able to use micro-lensing techniques. The number of times that technique gets used in astronomy for looking for exoplanets, for probing distant galaxy clusters, and so on and so forth. And now to find black holes in, as you say, our local region of space, really very impressive piece of snooping and sleuthing by this team.
I think they got lucky because this particular black hole is decidedly isolated, or otherwise they wouldn't have been able to test that technique to this extent, actually. That's why
it's very true. A dash of luck goes a long way. And I don't care what area of science you're talking about, being in the right place at the right time or doing the right thing, you can plan all you like, but a dash of luck is helpful for this sort of thing. So I suspect this technique is going to be utilized more and more. It's with more telescopes coming online, with their ability to do surveys and pick up these sort of transient events, expect this to be seen more often, which I think is very, very exciting.
Absolutely.
Voyager, I think you have a slightly sadder story to tell us.
Yes, I do. So recently, I believe about 4 to 5 days ago, the latest set of Starlink satellites launched by SpaceX. So there were around 49 satellites launched. They were hit by a solar storm and knocked out of orbit. SpaceX has said that almost 40 of the 49 satellites have either re-entered Earth's atmosphere and burned up, or are on the verge of doing so. And the reason why this happened was because of the increase of drag on the satellites due to the geomagnetic storm. The drag increased, slowing down the satellites, and they could no longer maintain their orbits. So they slowed down substantially and began to re-enter Earth's atmosphere. These the other factor that contributed to this was that they weren't at the location that you would usually find Starlink satellites. They were at a temporary location that SpaceX launches them to in order to make sure that if there are any malfunctioning satellites, that they'll just re-enter Earth without damaging any other satellites in the process. And so these satellites were in that temporary position. They did attempt to save the satellites by putting them in a hibernation mode and tried to put them in a higher orbit, but the drag from the geomagnetic storm was too high in order to do that, and they've lost at least 40 of them, or close to 40 now. At the moment, there are, however, 2,000 other Starlink satellites located in orbit at 550 kilometers. So they do have quite a few satellites up there, but they did lose most of the ones that they launched last week, which is kind of disappointing.
Especially if you're hoping to latch on to a high data rate internet signal from the constellation set. That is true. That is true. I mean, it shows you the importance of monitoring the sun. You know, if you are in orbit with a satellite, or if you are a space tourist in orbit, you want to know when the sun is getting energetic so that you can sort of take refuge. These satellites show what can happen when the sun decides to unleash a little bit of unexpected activity and swell the Earth's outer atmosphere. And as you said, Palvisha, generate increased friction, increased drag on the satellites. They were in just the wrong place at just the wrong time because they were in this vulnerable state. If it had happened, say, 3 or 4 days later, the spacecraft would have been en route to their higher orbits and probably would have survived the increased drag, but didn't happen that way. So, yeah, the sun is not to be denied. When it gets going, it can really influence terrestrial life, shall we say.
That's right. And they were just in the temporary position too, which is very disappointing. I'm sure they tried a lot to be able to pull the satellites out of that position and make sure that they would be okay. But again, not at their usual place, wrong time.
I wonder whether or not as well, you know, SpaceX wasn't monitoring solar activity. You would think that there might have been a bit of warning that there was a geomagnetic storm en route to us, and therefore could have delayed that launch of the Starlink. I don't know if you know, it might have, you know, the warning might have come literally hours after they launched, but it just shows that you need to keep an eye on so many differing factors when it comes to launching spacecraft.
That's just 5% error margin, right? Sorry, no.
A 5%? 5% of.
Sorry.
Oh, well, we lost 40 out of 49, so we lost 80%.
Yeah, I should have said the other answer. Yeah.
Yes, that's right. Now, in the grand scheme of things, I'm sure SpaceX is not overly concerned, but you know, not many people can wipe out 80% of their assets and go, it was a bad day, and then just launch 50 more. Impressive. Speaking of sort of Starlink satellites and so on, the International Astronomical Union has just formed a new commission that is to help fight for better regulations around both optical satellites as well as radio communications to be able to keep the sky quieter. Everybody is aware, in astronomy at least, that these constellation satellites do pose an increasing optical hazard's not the right word, but interference, shall we say, with our observations. And about 10% of all Hubble Space Telescope observations, for example, are compromised now by Starlink satellite streaking. And of course, the more signals we put up there, the more interference at the radio frequency spectrum are we receiving. So the IAU is now out there lobbying hard to try and protect against this erosion of a quiet sky. So we should probably talk about that in the weeks to come.
I read that within this article as well, actually. It mentioned that there were other private companies trying to put up satellites as well. And there's concerns that it will make observations a lot more difficult with the satellites there.
Oh, it certainly will be. And in fact, last week or 2 weeks ago, there was a group called, I think it was One World, that launched 49 satellites for their constellation. So, yeah, SpaceX is not the only crowd who is launching these relatively numerous small satellites into low Earth orbit, and they all do contribute to making the sky noisier at both optical and radio frequencies. So this is not good. There needs to be a little more oversight, a little more planning, a little more thought put into this. Okay, let me just touch base on our final news item. Proxima Centauri. Everybody knows, of course, and I won't ask my esteemed hosts where Proxima Centauri is, but Proxima Centauri is the closest star to the Earth, 4.2 light years away. Wonderful southern hemisphere star, part of the triple star system of Alpha Centauri. So anybody who is visiting the southern hemisphere, look for the Southern Cross, check out Alpha Centauri. The big question, of course, has been for decades whether Proxima Centauri has exoplanets orbiting around it. You recall our first exoplanet was found back in 1995, 51 Pegasus b. It was a hot Jupiter. Does Proxima Centauri have stars? We answered that. Stars, yes, Proxima Centauri does have stars. Does it have planets? We answered that question in 2016 categorically with the Pale Red Dot project. It was a combination of many assets of the European Southern Observatory and other astronomical facilities, putting together enough data, simultaneous observations, to clarify whether or not Proxima Centauri did in fact have an exoplanet. Proxima Centauri b orbits around Proxima Centauri. It's an M dwarf star, by the way. It's about a tenth the mass of our own sun, so it's a pretty lightweight object, has much less luminosity. But Proxima Centauri b, or Proxima b, orbits around about 11 million kilometers away from the parent star. It's about 1.2 times the mass of the Earth. That is an 11-day orbital period, by the way, not 11 million kilometers. It's an 11-day orbital period, 7.5 million kilometers out from the star. So no question in the world, we do have at least one planet around Proxima Centauri. Of course, when that came out, the news was very exciting. Was there the possibility of life there? The image that came out with the observations showed rolling surf and waves and water, which was all completely fictitious. We don't know is the bottom line to it. If there's a good solid atmosphere around Proxima b and there's a good magnetosphere, then it's possible that there is life there, or at least water. But we really don't know. But obviously one planet. Are there more? There was tantalizing evidence of this radial velocity discovery. Maybe, just maybe, there was another exoplanet there. And in fact, Proxima Centauri c was released, the observations were made, and then the announcement was made in 2019 that yes, Proxima Centauri c does exist. This one is a little chillier. It's much further out. Its surface temperature is like 39 degrees above absolute zero. Definitely a little chilly. 5-year orbital period, about 1.5 astronomical units from Proxima itself. That's two. Is there another one? There is. Proxima Centauri d is now being examined. It is much closer than Proxima Centauri b, only 4.3 million kilometers away from the parent star, and probably about a quarter of the Earth mass. In other words, we have definitely got ourselves a solar system which looks pretty impressive. Proxima Centauri b, c, and d. Folks, we are at the top of the hour. You've been listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory. Satish, Palvisha, and myself, Paul, been keeping you company tonight. Please stay tuned for the rest of Astronomy Night in Canada with Quirks and Quarks, Science for the People, not to mention Western Worlds. We will not see you next week. It is a holiday up here in Canada, so 2 weeks from now is the next time you will see us. 2 weeks from now. Good night from me.
Good night, all.
Good night.